Now I'm going to show you how to change your program profile. So you press your AM key to enter programming profile. And now I'm going to show you an example. Say you want to set your program to hold the temperature at 800 degrees Fahrenheit for 12 minutes. So first I'm going to change SYL-1 to 800 degrees. I'm going to change TO1 to 3. Next, I'm going to change CO2 to 800. I'm going to change TO2 to 12. I'm going to change CO3 to 800. I'm going to change TO3 to negative 121. And I'm just going to make sure all the rest of the unused steps are either at -1 or 0. Alright, perfect. So now I'm going to start the program. During the first example, I noticed that the controller went to step 2 before the temperature reached 800 degrees Fahrenheit. That resulted in the soak time during the second step. Now, how do we make sure that the temperature is reached before we go to the next step? The solution is to use a safety start feature. This feature allows us to program a temperature range to make sure that the timer will only start counting once the measuring temperature falls into that range. This particular range is called a deviation range or safety range. This range is defined by deviation alarms and the hysteresis band. At the beginning of a step or when powering up the controller, the program will be put on hold if temperature is out of the safety start range. If the temperature falls within the safety range, the timer of the current running step will start counting. Once a step starts running, it won't be put on hold, even if the temperature falls out of the safety start range again. The safety start feature is useful for when the user might need to be very specific about the temperature and the time of a step. Now I want to activate the safety start feature on my PID. So I'm going to go into my parameter settings mode. Making HY1 3. Making HY2 3. And keeping HY as the default setting, or 0.3. How do you program commands for special events? Well, this rampant soak PID controller allows the program to handle special events, such as pulling or dropping off relays, jumping to another step, holding the program, or stopping the program. When I was showing the first example, you probably already noticed that the controller has a C parameter for temperature setting and T parameter for time setting for each programming step. When T is between 1 and 9,999 minutes, it is used to set the step time in minutes. When T is set to 0, the controller will be set to hold mode. When T is set to a negative number, it is used for executing special commands. So now it's been a while, and I've already checked my program step, and it seems to be it hasn't run yet. And so I can check this by pressing the set key once and seeing that it's still in step 1. So, and the reason why is because the set temperature cannot be significantly lower than the ambient temperature, actually. And our ambient temperature here is 90 degrees. So by setting it at 70 degrees, actually the timer isn't starting. So I'm gonna go ahead and click A/M to change my CO1 to 100. So slightly higher than our ambient temperature of 90. Now I'm just gonna quickly check step 1 just to make, or just click set, just to make sure that our Okay, and we can see that the program actually did start and that it actually did run. Okay, now my program is finished. I'm just gonna check the step. Now I'm gonna restart my program by holding the down arrow key. I'm just gonna check this step, make sure that's at step 1. And say I wanna jump manually to another step, then I can do this by pressing the set key once, and then going to say step 2, and then pressing the set key to confirm this change. And just to see if the jump worked, we can check again and see it has jumped to step 2.